Okay, ready? Here we go. So let's review just the derivatives involving combinations. This is what we did Friday. So when we have more than one function, we can put them together in different ways to make a new function. So when you have two functions at their product, what is, in words, what would that rate of change be? Okay, so for time's sake, we'll just say, so it's the rate of change, or it's the first times the rate of change of the second, plus the second times the rate of change of the first. This is called the product rule. Product rule. Here's what the symbols look like. The first times the rate of change of the second, plus the second times the rate of change of the first. Okay, here order isn't required to have the order just right? You could switch, you could switch the sum, you could switch each product, you get the same result. Okay? Quotient. So here's our, for the sake of not having a long explanation here, low, d high, so the numerator times the rate of change of the denominator times the rate of change of the numerator minus the numerator times the rate of change of the denominator, and all of that divided by the denominator squared. And that's our rule for that. This, you have to have it right, because subtraction is not commutative. If you subtract, you switch the order in subtraction, you get the opposite. You don't get the same value you do as if you switch the order in addition. Okay, and then the last one was a rate of change of a composition of functions. So let's, from here on, when we talk about composition, to make things easy, or the easiest we can, is we're going to use the language exterior function and interior function. So for this one, I want you to see if you can form a statement using the words exterior function and interior function to describe what the rate of change of the composition of functions is. Practice with the person next to you. So can you say that in words using exterior function and interior function? Go. Okay, so start with, see how this compares to what you said. It's the rate of change of the exterior function with respect to the interior function. You're going to leave that interior function intact when you take the rate of change of the exterior function, and then times, this is where the chain comes on, chaining on, times the rate of change of the interior function. Is that what you said? Okay. So that's what it is. This is what this looks like. If G is exterior and F is interior, then we're taking the rate of change of G with respect to F times the rate of change of F. Okay, so let's, first, before we get into some examples, let's do a couple trig ones. So the rate of change of sine x is cosine x. Okay, prove it. Can you prove it? Here's the factional need. Sine of A plus B is sine A cosine B plus cosine A sine B. Actually, I didn't double check that. Is that right?
Yeah.
Is it?
Yeah.
Those who remember your trig? Okay. All right, and then sine A divided by A, as that approaches 0, that will approach 0 as A approaches 0. Okay? So, take a minute. See if you can do it. At least everyone should be able to start with the right start on this. So I want everyone to try to at least start it. And then from there, see how far you can make it. So we'll say f of x equals sine x. By now, everyone in this room should be able to write the first step. If you can. Where have you been? Where's your brain been? You're either making progress or you're getting help. So let's walk around. I want to see the first step. Use it.
X plus
Right.
yeah. It's
Yeah.
Yo, you think that
It's actually the limit. So let's do R. Okay, so that's our rate of change function. So we still had limited success getting that. So now we can apply the sign of A plus B. So it'll be sine X, cosine H, plus cosine X, sine H. That's that right there, minus sine X, all over H. Okay, what can we do now? So notice these two terms both have a sine X in them. Shoot, did I give you the wrong thing here? No, that's right. That's right. Okay, so then you can, out of these two, we can factor out sine x. So sine x times cosine h minus 1 plus cosine x sine h. And so we can take each one of those separately over h. Oh, I guess I needed to give you something else. Okay, so now we think about what would happen as h got very, very small. And so that's where this comes in, but I actually left off one thing. So as h gets very, very small, what does this become? It's supposed to be 1. This is, sorry, I blew it. This goes to 1, right? No, oh, right. Okay. So this goes to, as this goes to 1. Okay, so if you got this far, that's good. If you got this far, good. So what this really is this ratio sine a over a goes to 1 as a goes to 0. Okay? So this right here, as h gets very, very small, this becomes 1, and this thing is cosine x. Here's another fact that you needed. As h gets very, very small, that goes to 0. So sine x times 0 is 0. So as h gets small, our rate of change, sine x plus h minus sine x over h equals cosine x. So that's where the rule, when you use cosine x, is the rate of change function of sine x. Here's the math behind that shows that. Anybody have a question on that? Okay, so another one from your list is that tangent x equals secant squared. Now this one, we're not, so we could start with the same thing. This might be one way to start that, but there's another way to start that. You can start it by saying, oh, well, tangent is sine divided by cosine. So rather than starting with the difference quotient, our constant rate of change for change of x of h, we can start by changing tangent to sine over cosine and find the rate of change of sine over cosine. So that's what you're going to do. So find the rate of change of sine x divided by cosine x. I'll give you a minute. See if you can do it. What would that equal? So this proof becomes a valid mastery test problem. Right here. Everyone, so this sine x divided by cosine x. That could be on the mastery test. In case you decided to check out.
And so, if that's a valid problem, if you just memorize the rules, you just write.
Right, that's what mastery test is, memorizing the rules. So what's the rule?
Okay.
What rules in play here? No, I'm asking a question. What rule is in play here?
Right here.
What rule? Okay, so in all problems, you ask yourself, what's the overall structure? What's the big picture that governs how you start and the big picture of the rate of change function? So what's our structure of this? Quotient. So we're going to apply the quotient rule, which is low d high minus high d low over low squared. Hopefully everybody got that. What's the numerator? Cosine squared x plus sine squared x, which equals 1. That's the Pythagorean identity. 1 over cosine squared x equals? Secant is 1 over cosine. So 1 over cosine squared is secant squared. Any questions? So that's showing that secant squared is the rate of change of tangent. Yes, sir. No, it's prime. That's the same as rate of change. Same as rate of change. Other questions? Yeah. So if this were a mastery test, it would just this would be done. You'd be done. Yeah. If this was a mastery test problem, you would write this down and you'd be done. Okay. So do the first step and stop. But we were proving that tangent was secant squared. So this would not be done if you're proving it's secant squared. So we had to do this to finish the proof. But on the mastery test, you write down the first step and you stop. You don't do any simplification.
Awesome.
Right. Everyone got it now. On the mastery test, you do the first step and then you stop. Don't do any simplification. Okay. Yeah.
I guess if they ask for the derivative function, if you broke down the difference function, the open form and that form.
No, this is memorizing the rules. Mastery exam is about memorizing using the rules. It's not about the open form. Yeah. Okay, let's practice up these, okay? These are all just one-step chain rule problems. Let's do the first one together. So remember that the chain rule says you take the rate of change of the exterior function with respect to the interior times the rate of change of the interior function. So we need what's the exterior function? So what's the rate of change of our exterior function? Okay, negative sine of what? With respect to the interior function. You leave it as it is. So remember, it's the rate of change of the exterior with respect to the interior, then times the rate of change of the interior function. Questions on that one? So this should, from Friday and from web work, you should have a lot of little ones like these. Let's do a few more. Try these. Go.
say to them too that when you say one step and stop, they may write it like if they had a quotient rule or chain rule, they might use prime notation in their first step. So like say something like no primes, no ddx's, all derivatives need to be evaluated.
Okay, we'll do that. Yeah. So on the next one, we'll do that. Yeah. I wrote a couple rules in the upper right hand corner if you haven't learned yet.
Yeah, you don't have to. Yeah, that's what I mean by it. That's not. I usually. Okay, good. Multiply by 6. Yeah.
Okay, so let's talk about these first four, or these two through four. Any questions on those? Did we have success on those? Yeah. Yes, tell me. So what should it be? 3e squared? E cubed? Okay, e cubed is a number, a constant. It's a number raised to the third power. So many, common mistakes are to write, well, e cubed is the rate of change of e cubed. Nope. Or to write 3e squared. Nope. E cubed is a number. It's not a function of x. So once that's 0. So that would be it.
Yeah, it should be 2 squared of x.
2.
It's the 1 over 2. 1 over. It's not really. You said 1 over.
This?
Yeah.
Thank you. Sorry. I was thinking about that e cubed. Yeah. Nice. What? Yeah, that's the same thing. How about the next one? Okay. See how I applied that b to the x rule, but then since we had an interior function, then we need to hold on to it, right? Exterior with respect to interior, and then times the rate of change of the interior function. Are we good? Okay, so now here we've got a couple levels deep. So the whole thing is what? So it'll be 1 over 2 times. What will go in here? Exactly as it is. First. Wow. Where I am. Can't find where I am. Okay, so that's, what is that? That is the rate of change of the square root of this thing with respect to that thing. Okay, now times what? Times the derivative of that thing. So I'm going to put it down below. Okay, what is the derivative of that thing? 5x to the 4th plus, what's that? It's the chain rule again. Within the chain rule, you see that? So the rate of change of this is what you just found above, so it's that whole thing. Okay, and then this is product rule, right? ln of 10 times b to the negative 1/4. ln of 10 is a number. B is like a parameter or a constant relative to x is our changing input quantity here. So b is a constant. It does, as x changes, it stays the same. So the rate of change of this is 0. ln of 10 times b to the negative 1/4, as x changes, stays constant. As x changes, that stays constant, so its rate of change is 0. It's not 1 over 10, it's not negative 1/4 b to the negative 5/4. Why? Because that thing stays constant as x changes. So that expression there would be in your parentheses, and that would be this rate of change of that function. Questions on that one?
Do they get harder than that?
He asked the right question. Do they get harder?
In your answer, should you incorporate the -0, or should you just
Doesn't matter. Doesn't matter. I'm just showing it, but it doesn't change it if you have it or not. Okay, but so how about this? What's the overall structure? Isn't it a quotient? And then the denominator, isn't it chain rule? The third root, the x to the fourth. So if you're hesitating, that's good, because if this were on the first part of the first half, and you're only allowed to use one rule, then if you use the quotient rule and the chain rule, you're doing about 5 times as much work as you need to do. What can we do instead on this one? Use your rules of exponents. This is the same as, this is not the rate of change now. This is just equal to what? X to the negative 4/3. We got to know that, because, so in my past experience, students get a problem like this. Lots of them, they just go right to quotient rule, and then when they get to the rate of change of the denominator, they do the chain rule. And all that is unnecessary. If you recognize by the rules of exponents, that thing is just the exact same thing as x to the negative 4/3. And this is a lot easier. What's the rate of change then? Negative 4/3 x to the... No, you truly subtract 1. So you don't go closer to 0. On the power rule, you truly subtract 1. So it's going to be negative 4/3 minus 1, negative 7/3. Okay, so make sure you know your rules of exponents and roots. So if you get one like this, you're not doing the quotient rule and the chain rule. It's way too much work. So change it to x to the negative 4/3, because that's what it equals. Then just one easy step on the power rule. That's not one easy step. Okay? This is using rules in combination now. So what's the game plan? The game plan is, what's the overall structure of this? Is it a composition? Is it a product? Is it a quotient? This is a product. Okay? So therefore, we're going to identify, we'll call this, say, F, and we'll call this, I don't know, J, or something else. Use J. Let's just say P and Q. P and Q. P and Q. So, what will our overall answer in the end will be? Not that. That won't be the overall answer. All right, here we go. Okay, so rate of change of G will be the first times rate of change of the second plus second times rate of change of first. So what do we need to then write down the rate of change function? We've got P already, we've got Q already, so what do we need? We need the rate of change of Q and the rate of change of P. So the rate of change of Q. We look at this thing and we say we want the rate of change of that. What's the overall structure? A quotient. So when we do the rate of change of Q, we're going to apply the quotient rule. And it's going to be low D high, right? Low, there's low, D high, e to the 4x. What's the rate of change of e to the 4x? With exponential functions, it's always e to the 4x. But this is a composite, right? Because we have 4x plugged into e to the x. So then we need times the rate of change of the interior function, which is 4. So that's our rate of change of the numerator. So this is low D high, and then minus high D low. D low is what kind of thing? It's a chain rule problem, right? It's actually a chain rule problem we had on the previous page, and we found that chain rule to be 2 radical x plus e cubed squared times 1 over 2 radical x. So that's our low d high minus high d low for q, for the function q all over low squared. So something squared squared is to the 4th. Any questions on that? So what is this? This is the rate of change of q, which is one part of our product rule. It's just that this part right here. So what we found was this part right here of our final answer. Yeah, Trevor.
So you're saying on the mastering exam that
Well, no, we're not even done. So this is going to be right here. What we just did was this part of our answer. All right. Do you see? Okay, so our answer to this is going to be the product rule because our initial structure is a product. Okay, I need you to stop talking, please. What I put in the box is what the answer is going to look like, okay? But when we get to, in that, we have the rate of change of q, which is a quotient. So I've written out the rate of change of q. That will be, eventually, in the end, we'll fill in what I put there for q. Yeah?
Okay, so the expression you have in the brackets, you have the first section, which is 2 times an expression from e squared. It's not supposed to be squared because that's
To the first, right?
right. If we made a mistake like that, what effect would it have?
So like, if this is a 5-point problem, that'd be 1 point off. Yeah, so if this is worth 5 points, then missing an exponent would be 1. Something like that. Yeah. A bigger mistake like forgetting a whole piece of it, like, would be 2 points off. Something like that. Okay, so then, what do we need next? So our goal is this here, right? So all that's left now is we need the rate of change of p. And what's that? P is another quotient, so the rate of change of p will likewise be another quotient. So we'll have low d high. There's low d high. So what is the rate of change here? That's the rate of change of the numerator in the p function. Minus high d low. So now we're doing the rate of change of the denominator here, which will be 1 over, should be familiar, natural log of 5 times all over this log thing squared. Okay, and so then the answer, we're ready to write the answer. And writing the answer would be writing P, then writing times the rate of change of Q, and then plus writing Q, and then writing that. So everything's on the page somewhere. We just have to write it in this order. P times the rate of change of Q plus Q times the rate of change of P. But we're out of time, Rat, so I don't get to write that out.